Well, today we focus our discussion on the next topic, which is known as density. The word density means, in Hindi, we call it ghanatva. What we mean by density? Density is the mass of the substance and volume of the substance gets involved into it. If we need to define it mathematically, I would put it as density is mass per unit volume, the mass of the substance per unit volume. When you have a spoon of sugar dipped into, or when you mix it with water, the density of water actually increases because you have added sugar to this. Let us suppose that in this room, we all are sitting. How many of us are there? Let's suppose 40 of us are there in this room. Now, another 50 people joins in. Now, the amount of space that you are enjoying in this room, with another 50 people joining in, do you think that the space would remain same, or it is going to decrease? Of course, it is going to decrease. That means with the increase in mass, the density is going to decrease, the volume remaining same. So we find that the density and volume are inversely proportional to each other. When I say inversely proportional to each other, I mean that if the volume increases, the density would decrease and vice versa. The book says some substances appear to be heavy, whereas others appears to be lighter. For example, iron is heavier than aluminium, and water is heavier than alcohol. So when we talk about density, it's the heaviness or the lightness of the object that we are actually talking about. The SI unit of mass, we know it's kilogram, while that of volume is meter cube. So when we are looking out for the SI unit of density, it must be kilogram per cubic meter or kg per meter cube, and we write it as kg meter to the power minus 3. If we talk about some of the densities of commonly known substances, we would find that if I consider the density of water to be 1000 kg per meter cube, we can take it as 1000 kg per meter cube. Then cork, cork, wood, and ice are lighter than water, while glycerine, glass, aluminium, iron, mercury, and gold, these happens to be heavier than water. So if I dip a cork into water, or maybe a piece of wood or ice into water, you'd find that they will float, because if you check, ice is having a density of 920 kg per meter cube, while that of water is 1000 kg per meter cube. And if you remember, when we were discussing about buoyancy, we have discussed about this. The ones which are lighter will be floating, but at the same time, when we have iron, or say a piece of glass which is having density 2500 kg per meter cube, or iron which is 7800 kg per meter cube, they will be sinking in water. Can you see that? Please focus on the table. So when we say that the density of water is 1000 kg per meter cube, what we actually mean by that? By saying that the density of water is 1000 kg per meter cube, we mean that the mass of 1 cubic meter volume of water, I repeat, the mass of 1 cubic meter volume of water is 1000 kilometers. 1000 kilograms. I am so sorry, 1000 kilograms. 1 cubic meter volume of water, the mass of 1 cubic meter volume of water is 1000 kilograms. Got it? Think about this: wood and iron, they have densities of 800 kg per meter cube or 7800 kg per meter cube. One will, of course, they will sink, the other will float. Many times smaller unit of density is called gram per cubic centimeter is also used. We write it G per cc, gram per cc. where cc means cubic centimeter. Cc means cubic centimeter. The same thing, if it is divided by 1000, you will be getting these values. Have a look. The same values that we have in the previous table, here they had been converted into gram per centimeter cube. Water would be considered to be having 1 gram per cc density, while that of ice, wood, and cork would be 0.92, 0.8, and 0.24 gram per cc respectively. Similarly, we have it for glycerin, glass, aluminium. These are the different substances that are heavier than water. As I said, the density of any substance is one of its characteristic property. If the density of a substance is more than the density of water, then the substance will be heavier than water, and hence, what would happen? It will actually sink. While on the other hand, if the density of a substance is less than the density of water, then the substance will be lighter and it will be floating on the surface of water, right? With this information, let us try with a small numerical. Are we all ready for it? Check out with this. I said density is mass per unit volume. If the density is mass per unit volume, over here the question says the mass of 2 meter cube of steel is 15600 kg. What is it? The mass is given to be 15600 kg, and the yes, and the volume is given to be 2 meter cube. So we are asked to find the density in the SI unit. What should I be writing? I'll be using the formula density is mass by volume, put these values in, and I would be finding that the density of steel is around 7800 kg per meter cube. In fact, this density plays a very important role when designing various objects. We talk about a plane. An aeroplane is made up of aluminium. In fact, the body, when it is made up of aluminium, it becomes very heavy. So what we tend to do, we tend to make the body with an alloy which is known as duralumin. Aluminium is replaced by duralumin. Let's look around with which is when I talk about duralumin, this alloy is much stronger than aluminium, but very light. Thus, when we make make the body of the plane with this substance, the plane becomes lighter but stronger. Let's come to the next question. It says an object of mass 50 gram has a volume of 20 centimeter cube. Now check over here again, the mass and the volume has been supplied to you. The mass is 50 gram and the volume is 20 centimeter cube. You are asked to find the density of the object. So to find the density of the object, we know what our formula is. It's mass by density, a mass by volume. We put in the values and we find that mass of the object is 50 gram by volume of the object being 20 centimeter cube. It's 2.5 gram per cc. Now the question arises, the second part of the question says, if the density of water is 1 gram per cc, check whether the object will float or sink. Now, my dear students, you can check over here, the density of the object 2.5 gram per cc is higher than the value of density of water, which is 1 gram per cc. Thus, what would you suggest? Will it sink? Will it float?
Sir, it will obviously sink.
It will
Yes, it will sink.
it will sink because the value is higher than the value of water or the density of water. Let us start with another topic which is very closely related to this, which is known as relative density. Just now we have talked about what? We have talked about density, and I said density is mass per unit volume. What is relative density? Now, a few minutes back, you just tried to compare whether the body will be floating or sinking, isn't it? How did you do that? You compared that with a standard, which in this case you took as water, right? Exactly
Yes.
the same thing we are doing over here. When we talk about relative density, we say the relative density is a ratio. And since it's a ratio, it's a unitless quantity, remember. It's a ratio between the density of a substance to the density of water at 4 degrees Celsius. Well, the screen shows density of water, but I would like to add there as 4 degrees Celsius. There is a reason to that. When I say there is a reason to that, it's because, let me explain it this way. You all are aware that water, ice, and water vapor, can change, they are interchangeable in their phases, right? So when we talk about water, what would happen if I heat that water? The water would evaporate, right? You all agree with me? Now tell me, guys, if it is evaporating, what happens to its molecular, distances? In a liquid, the distance between the molecules are comparatively less, they are less separated than and that in a gas. When we talk about a gas, the gaseous phase, we would, we would say that the molecules are far more separated than that was in the liquid phase. That means with the application of heat, with the addition of heat rather, what we find, with the addition of heat, the molecules get separated. Now let's talk about freezing. The same water, if I put it in the freezer, what would happen? The molecules come closer, they solidify and turns into ice. That means when I take heat away from the substance, or if I take the heat out of the substance, what happens? The molecules come closer, right? Well, this is something which is happening with almost all the substances barring a few, and water is one of them. So for water, we have anomalous expansion of water. What do I mean by anomalous expansion of water? Well, till 4th degree, whatever is the common phenomena is being followed. Whatever the common phenomena, that the till 4th degree, all the molecules are coming closer to each other. But the moment it reaches 4th degree, it starts moving away. That means there is an expansion at that point, and that's why we call it anomalous expansion of water. We take that as the reference point. We take the density of water at 4 degrees Celsius because of that. I'll just narrate a small point over here. Since you all are from this part of the world, you would be knowing there is a lake called Changu Lake. I hope you are aware of this lake called Changu Lake, which is there in Sikkim. Now,
Yes, sir.
what is the unique thing about this lake? During the winters, the water get frozen, and because the water get frozen, you can walk on that lake, right? That's the unique thing about this lake. Now, have you ever thought, is the entire lake getting frozen? Is the entire lake getting frozen?
No,
Or
sir.
is it
Only the
just
top
No,
sheet
sir.
is getting frozen.
only the
Only
Only
the
top
top
sheet.
surface
sheet?
of the water.
Very good, very good. That shows that you people are inquisitive and you have actually collected informations regarding that. Whenever a pond, or for that reason a lake, get frozen, is just the top sheet, so that the aquatic plants and animals can be protected. By how does that happen? It's because of this anomalous expansion. In fact, I can give you another example of this from real life. I don't know how many of you have ever been to uh, a field. Uh, if you see during the winters in the field, the farmers, they pour a lot of water. They pour a lot of water on their fields, and that's because water beyond 4 degrees Celsius starts expanding. Why do they do that? So that the capillaries of the plants that are there, they should not burst. Of course, there is a concept of heat involved over there. Well, so that the capillaries of the plants do not burst and the plants do not dry, because they need to be protected so that they do not die. We put a lot of water on the field, so that even if the atmospheric temperature goes down below sub zero, even then the plants are protected. The plants get the nutrients through their capillaries. Well, coming back, we just now said the relative density of a substance is the ratio of the density to that of density of water at 4 degrees Celsius. How can we again reframe and put up another formula in the mathematical form? See, we know density of a substance is nothing but mass of the substance by volume of the substance. That goes same for water as well. So if I put it as seen on the screen, that the relative density of a substance is mass of the substance by the volume of the substance into mass of water by volume of water, we would find that after they get cancelled off, density, relative density of a substance can be described as mass of the substance by mass of water, mass of water, right? Which kind of water? Equal volume of water. So the relative density of a substance is the ratio of mass of any volume of the substance to the mass of an equal volume of water. Right? Since it's a ratio between two similar quantities, may it be masses, may it be densities, may it be volumes, so it's a unitless quantity. There won't be any unit. So my dear students, this can be a small question that can be set during your exams, which can ask you why relative density is a unitless quantity, or it can be reframed in a way, what is the SI unit of relative density? Well, my dear children, please don't go get bowled away by this. This is a question that is set so that you people can actually use your wit a little bit and answer this question. Again, relative densities of some common substance. When we talk about the relative densities, we consider the density of water at 4 degrees Celsius to be 1. We'll consider that to be 1, and then calculate the densities of others. That's how we, it comes up. For a cork, it's 0.24. For wood, it's 0.8. For ice, it's 0.92. That means these are all lighter than that of water, so they come above water. But when we talk about glycerin or aluminium or glass or mercury, we find that they are heavier, so they have relative densities which are higher than 1. The relative density of a substance expresses heaviness the heaviness or density of a substance in comparison to water. The relative density of iron is 7.8. What do we mean by that? By saying that the relative density of iron is 7.8, we mean that iron is 7.8 times. How many times? 7.8 times as heavy as an equal volume of water. Thus, the relative density of a substance is the number which tells us how many times the substance is heavier than an equal volume of water. Again, this might be set up as a question. What do the value relative density of iron is 7.8 suggest? You can get a question like this. I'm just trying to frame it my way, but your teachers might put it in a different way as well. The questions might come it in a different way. You can check with your sample papers for the last few years, and you'll be getting that this kind of questions, they did appear in your terminal papers, or maybe in any kind of tests. The relative density of iron is 7.8. Comment on the statement. This kind of a question. Relative density is very important in the accurate determination of density. Actually, the relative density of a substance is found accurately by using Archimedes' principle, as this relative density is then used to calculate the density of the substance. Did you get that? We'll just focus our attention to one of the numericals that is given over here. Let's check over here. The question says, the relative density of silver is 10.8. How much is that? The relative density of silver is 10.8. If the density of water be 1 into 10 to the power 3 kg per meter cube, calculate the density of silver in SI units. Well, if you know the formula, it's a pretty simple one. Relative density of the substance, how much is that? 10.8. What is the density of water? It's 1 into 10 to the power 3 kg per meter cube. So what is the density of the substance? Simply multiply. If you multiply, you'll be finding the density of the substance is 10.8 into 10 to the power 3 kg per meter cube. Wasn't that easy? Wasn't that easy?
Yes,
Yes,
sir.
sir, it was.
Yes, sir.
So it says the density of a substance can be obtained by simply multiplying the relative density with the density of water. Well, my dear students, check over here. You may be, given a combination question. You can be given a combination question. I'm discussing the questions alongside my lecture because this will help you understanding to focus on which part. It may be the question might be you would be given a particular value and you would be asked to find the relative density. And once you find that, you also might have a small numerical related to this. This one is a simple one. So taking both these together, it could be a 2-mark question. It could be a 2-mark question, or maybe if your paper stated is a generous person, he might give a 3-mark question as well for this. But I would suggest this would be a maximum 2-mark question. It hardly involves any calculations as well. Let's check with the next question. The volume of a solid of mass 500 gram is 350 centimeter cube. Well, my dear students, please check over here. If you check this question, it talks about the mass and the volume both in CGS system of units, isn't it? It talks about the CGS system of units. So once we calculate this, what should we be comparing with 1,000 or with 1? If you remember, we have shown you 2 tables. The first table actually talked about the SI system of units. The next one talked about the CGS. So this is basically the CGS system. So we have got what the density of the given solid is 1.42 after calculations. Next part of the question, let's check what does it say. It says what will be the density of the solid, which we have already found out. What will be the mass of water displaced by the solid? Now, my dear children, if I need to find the mass of the substance, mass of the water that will be displaced, we can do the calculations in the similar fashion. Will it float or sink? Well, if it is higher than the value 1 gram per cc, it will be sinking. But if it is lower, it would be floating. Let's see the approach that they have actually taken. If you check over here, we're finding the density of water is mass of water by mass of the volume of water. So if I need to find the volume of water, what am I supposed to do? What am I supposed to do over here? I just put in the values. I find that the mass of water that would be displaced is 350 grams. 350 grams, because we are already provided with the information regarding density as well as the volume. So if the mass of water needs to be calculated, it simply we need to multiply that. Another question that was asked about was about the relative density of the solid. So when we talk about the relative density of the solid, it's the density of the solid by the density of water. So density of solid, if you check, we have found it out to be 1.42 gram per cc. Do you find that? Do you find that on your screen? It's 1.42 gram per cc. I've
Yes,
highlighted
sir.
that. Now, if you come down, you would be finding over here the relative density of the solid is 1.42 gram per cc by 1 gram per cc. If they cancel off, we are left with relative density to be 1.42, which is higher than 1. Since it's higher than 1, what would happen? What is expected? It is going to sink. It is going to sink. And actually, this is how it looks like. If you check with all these informations that I've shared in the class, you'll be finding these are the concepts that are being discussed. Iron nail, if you see, if you drop in water, it would be sinking. But the same iron nail, if you put it in mercury, you'd be finding that it's floating. And why is that so? It's because the density of iron is less than that of mercury. So it will be floating over there. Similarly, when you talk about icebergs and all, we find that they float in water. Why do they float in water? Because of the density of ice being lesser than that of water. We also talk about wood. It's always said when you go for a swimming lesson that whenever you are drowning, you should hold on to either a tube, air-filled tube, or a wooden block, whichever you find nearby. That's because wood or a tube filled with air is a density which is lesser than that of water. So it would be floating. Do you get all these points that I have just discussed? I would rather now prefer taking up questions from you all.